Number 21 here in 3.3, the directions here just say to calculate the derivative of this function given to us. I like this problem because there's actually two different ways of doing this that of course should get us the exact same result. So let's do it kind of the normal way here. In section 3.3, we're working on the product rule and the quotient rule, and I think, hopefully clearly, this is a product rule problem. We have a binomial here in parentheses, the square root of x plus 1, being multiplied by a second binomial, the square root of x minus 1. So, to calculate our derivative, which is going to be f prime of x, we are going to apply the product rule, and you can do this in either order. The way I've always liked it is to leave the first term here alone, and then take that times the derivative of the second. So, the first factor then is just going to remain the square root of x plus 1, but then we're going to multiply that by the derivative of the second factor here. So inside that binomial right there, the derivative now of the square root of x, remember guys that this is really an x to the 1/2 power, so the derivative of that would be 1/2 x to the negative 1/2 power. So you certainly could write it like this, 1/2 x to the negative 1/2, but it's probably going to be beneficial for you guys to realize that that derivative right there can be rewritten in a way that's probably more beneficial to write it this way. The 1/2 is just your 1 over 2 now, and then the x to the negative 1/2 power is going to become a square root of x located on the bottom of that fraction there with the 2. So that format that I have there in red is usually the more useful version of it, so I'm going to write it then as 1 over 2 times the square root of x. Then we would need to take the derivative of the second term, but since negative 1 is a constant, that derivative is just 0. So right here, guys, where we are right now in blue, that's half of the product rule. First factor times derivative of the second. We're going to add to that now the second factor, untouched, so the square root of x minus 1. Multiplied by the derivative of the first. And this derivative now, again, we have the derivative of the square root of x, which as we just talked about is going to be 1 over 2 root x. And then the derivative of the plus 1 is going to be 0 as well. So what we have right here, guys, let me go ahead and get rid of this. What we have right there on that second line in blue is the derivative of this function. And on a quiz or a test question right there, you'd have at least half, if not even more than half, of the points on a problem like this. Now it's simply a question of simplification. And one thing we probably all noticed right here is that we have a large binomial here, term number 1 plus term number 2, but those two terms have a common factor. So what I'm going to do is factor out that common factor here of 1 over 2 root x, and then just start a set of brackets right now. What's left over after we pull that out? Well, we've got a square root of x plus 1 that came from right here, a plus that came from right here, and then a square root of x minus 1 that came from right there. Okay, so now what I hope we notice is that inside those brackets, the plus 1 and the minus 1 cancel each other out, and we end up with a 1 over 2 root x, and then multiplied by root x plus root x is going to be 2 root x. And that's interesting now, because what I notice here is that my fraction's denominator, 2 root x, is exactly the same as what it's being multiplied by. They're just going to cancel each other out completely, and we're going to end up with our final answer here that f prime of x is equal to 1. So that's a little bit of a surprising result right there, but as I went back and looked at this problem and thought, something interesting could have been done initially, maybe that answer seems a little less weird than I thought. I don't know if anybody noticed it, but the original problem, the way it was written right here, guys, is actually the product of two conjugate binomials. This is like a plus b multiplied by a minus b. So one option you guys are always going to have, I'm never going to tell you that you can't do this, is to rewrite the original function in a way that might make it easier to differentiate. So if we were to do FOIL here, guys, first product times first product, root x times root x is just going to be x. Because these are conjugates, the outer product and the inner product are going to be opposites and cancel each other out. That would get us a minus root x and then a plus root x, and sure enough, those are just gone. And then your last product is plus 1 times minus 1. So the original function, the way that it was written to us, is equivalent to the function x minus 1. And now this became a much easier problem, guys, because if f of x is just x minus 1, that's a linear function, then f prime of x could be found simply by doing the power rule right here, and the derivative of x is just going to be 1, the derivative of that minus 1 is going to be 0, and that is another way of getting the exact same answer to that problem here. So I think this one pretty clearly was easier if we took a little bit of time to rewrite f of x in a different way, but then don't forget to take the derivative of that. A lot of times I've seen people say, oh, I'm going to rewrite this, and they come up with this, and then they just quit because they think that's their answer. Remember, this is still just a different way of writing f of x, and we needed to come up with f prime. So, more than one way to skin a cat there, guys. Whichever way you do it, this is our answer to 21, that our derivative, f prime of x, is equal to 1.